Hello, my amazing students. This is Mrs. A, and we are doing 10.1 in our intermediate algebra, and we're talking about the square root property. So the square root, remember we just finished all of chapter 9, and all of chapter 9 was about radicals and radical equations. To solve radical equations, we went through a process where we squared both sides of the equation. And we found out that it was legal to do that, but we sometimes wound up with extraneous solutions. Now we're doing chapter 10, and we're talking about the square root property, which basically is this right up here. If I have an equation that x squared is equal to something, some constant, or some expression, we'll find out later, it works with expressions, then x is equal to plus or minus the square root of k. Now, remember we have plus or minus because we know that 5 squared is 25, and we also know that negative 5 squared is 25, okay? So, remember back at the beginning of our chapter 9, we were talking about the fact that when we saw something like the square root of 25 in a radical, then we knew that that meant the positive or the principal square root. It's just a math convention that we've all accepted. When we see it already under the radical, then we know they mean positive 5. But in this problem here that we're about to do, you are going to take the square root. It is not already in a radical. Therefore, we have to go back to remembering that every number has 2 square roots. 25 has positive 5 and negative 5 that are square roots. And if I take the square root of 25, I do get one of those 2. If I have it already in a radical, then I know it's the positive one. But now we're going to start using the square root property to solve equations when one side is already squared. A little bit later on in this lesson, we'll figure out how to make one side a perfect square. But that will be a little bit later. So I'm going to erase these and let's do our first problem. Right, so we have g squared is equal to 36. So we know that the square root of 36 is 6, but we're going to remember that using the square root property, I need to recall that plus or minus the square root of 36, which is plus or minus 6, will be the answer, okay? And then t squared minus 60 is equal to 0 is not quite ready for me to take the square root. But if I go ahead and add 60 to both sides, then I get t squared is equal to 60. And then I can take the square root of both sides because I have the t squared by itself. And I will get t is plus or minus the square root of 60. I'm running out of board there. But remember that square root of 60 could be broken up into square root of 4, square root of 15, all right, and square root of 4 is 2. So 2 square root of 15 is the same thing as square root of 60. So I'm going to take this answer off and make it plus or minus 2 square root of 15. All right, so let's look at the next one. And of course, they get a little bit more complicated as we go along. Now, we're going to try to get the 2h squared by itself, but we need to take away the 59 from both sides. So we're going to say 2h squared equals 9 minus 59 is a negative 50. Okay, some bells and whistles should be going off in your head right now because we have something squared is negative. Now let's go ahead and divide by the 2. Get the h squared by itself. So we're going to have h squared is negative 25. And we know from the last section that we covered that that is going to be an imaginary solution or a complex number. but we're going to work it the same way. So I'm going to give myself a little bit more room here. And we're going to have h is plus or minus the square root of negative 25. So we're working it exactly the same way, even though it is complex. And then we're going to pull out our I, and we're going to split the negative 25 into the square root of negative 1, the square root of 25, and we're going to wind up with the square root of negative 1 being I. So I times 5. All right, so we're going to just put I times 5. H is 5I. H is 5I. So there's my answer right there. H is 5I, because I ran out of room. This one's pretty simple, because n squared is 49 means that n is plus or minus the square root of 49, which is plus or minus 7. Okay, and then this one has a quantity in the square. So I have a quantity squared, but I'm still going to be able to use my square root property in the same way. Let's see if I can adjust this a little bit. There we go. All right, so I'm going to take the square root of both sides and get p minus 11 is plus or minus the square root of 49. But we know that plus or minus the square root of 49 is plus or minus 7. So I have p minus 11 is plus or minus 7. Okay, so now this little process we're going to go through, we're going to do for all of the ones that we do in the future. When I have to get rid of a number here, I'm just going to add 11. And I'm going to add 11 on the right, but I'm always going to do it right in front of my plus and minus sign. So now I have two options for p. And wouldn't I expect two options for p? Because I have a quadratic equation. So I end up with p is 11 plus and minus 7. Okay, and then I evaluate the two p's that are possible. So 11 plus 7 is 18. So p is 18, or 11 minus 7 is 4. P is 18 or 4. Okay, so now look at what happens if I take those numbers, 18 and 4, and I go back into here. Then will it make it true? Let's try the 18. Let's put the 18 back in here. 18 minus 11 is 7. 7 squared is 49. That one works. Let's take the 4. Okay, 4 minus 11 is negative 7. And negative 7 squared is 49. So they both work. Okay, so now we're going to do some other problems. This one right here is already has a quantity squared, a square of a binomial, but we're going to use our square root property to get rid of the square. So I take the square root of the left side and I get 2f plus 5. I take the square root of the right side and I get plus or minus the square root of 16, which is the same thing as plus or minus 4. So now I've got to get rid of, I'm trying to get to my f, right? So I'm going to get rid of my 5. So I'm going to subtract a 5, and I'm going to subtract a 5 right in here in front of my plus or minus 4. So let's clean that up. We have 2f is equal to negative 5 plus or minus 4. Okay, so then we're going to divide everything by 2, divide by 2, divide everything by 2. Now, since both of these are real parts, we can leave them under 1, 2. But let's clean up that answer. Okay, so now we have f is equal to negative 5 plus 4. Well, that's a negative 1 over 2. So negative 1/2 is one answer for f. And then negative 5 minus 4 is negative 9 over 2. So negative 9 over 2. And both of those answers for f should plug back in and make the original equation true. So let me show that to you. make sure everybody got that one. All right, so here we have another binomial squared that we're trying to get rid of here. So we're going to take the square root of the left, 4d minus 7, and we're going to take the square root of the right, plus or minus the square root of 5. Now we've got a radical that's not going to come out, but we're going to proceed in the same manner. Plus 7 and plus 7 on the other side in front of the plus and minus. So we end up with 4d equals 7 plus or minus square root of 5. Okay, and then we're going to divide everything by 4 to get the d by itself and divide the right side by 4. So now we have d, and our two terms are not going to add together. So we basically have two different solutions that will not simplify. 7 plus the square root of 5 over 4 and 7 minus the square root of 5 over 4. Now we can write each one separately. 7 plus the square root of 5 over 4 and 7 minus the square root of 5 over 4. But it is also fine to leave it in this form. This is an acceptable form. 7 plus or minus the square root of 5 over 4. And then this is also fine to break them apart and put the two different answers down. Okay, so now we have another one. And right off the bat, I can see that this one is going to be complex or imaginary because I'm going to subtract the 20 from both sides. And I end up with m plus 3 quantity squared equals -9. Okay, so now I'm going to take the square root of both sides and get m plus 3 is plus or minus the square root of -9. Now -9 is going to split up into the square root of -1 and the square root of 9, which is going to be I times 3, or 3I. So we end up with m plus 3 is plus or minus 3I. We have an imaginary solution. And now I need to get rid of that 3, so I'm going to subtract a 3 here and subtract a 3 over there. And my final answer is going to be m is -3 plus or minus 3I. And again, I could write that out as two separate solutions. M is -3 plus 3I, or M is -3 minus 3I. There are two solutions, but this plus or minus notation is fine also. All right, so now we have a binomial squared is equal to 32. Okay, so we're going to take the 32 and put it on the other side, and it becomes a -32, another complex solution. So 2w minus 5, okay, I'm going to take the square root of that one, and on the other side, I've got the square root plus or minus the square root of -32. Now, 32 is not a perfect square. We're going to break this into a -1. We're going to break this one into a 16, which is in 32, and a 2. Okay, so 16 times 2 is 32 times the -1 plus or minus, so we end up with 2w minus 5 equals, and we're going to have plus or minus. This one turns into an I, this one turns into a 4, so 4i square root of 2 does not come out of the radical. So now we're going to add a 5 to both sides. So add a 5, and remember that 5 is going to go right in front. So we're going to get 2w is, this one cancels, 5 plus or minus 4i square root of 2. Okay, so we have one last step, and that is going to be to divide out our 2. Now, this is real and imaginary over here. So basically, my 2 is going to have to go in both parts. I can't write them all over one denominator. So I'm going to divide by 2. I'm going to divide, okay, so this side divide by 2, this side divide by 2, this side divided by 2. So let me write my answer right here so we get it all on the board. So we would end up with W equals, so we had 5 halves, 5 divided by 2, and then we had plus or minus the 4i square root of 2 divided by the 2, but since I have a 4 and a 2, can I just take that off altogether and write that as a 2i square root of 2? So we end up with 5 halves plus or minus 2i square root of 2 as my answer for W. And we are coming right back with the distance formula and the derivation of that. All right, one correction was on the very first board we did. I saw right here when I went back and checked all the answers that I had left my plus and minus because I got crowded here. So H is plus or minus 5i. And that was back on the very first board. So make sure that you make that correction. All of the other answers were correct. Now we'll come back with the distance formula. So now we're back with the distance formula, and we're going to derive the distance formula first. So I have drawn a line between 2 points, and since we're trying to derive a formula, I did not use 2 specific points. I used P1 and P2, and P1 is x1, y1, and P2 is x2, y2. So very nebulous, right? It should work for everything. Now, when we're deriving the distance formula, we're really going to go back to our good friend Pythagoras, okay? And I have some cool stories about him, by the way. Someday I'll tell you. But what we're going to do is we're going to form a right triangle. So we're going to take a straight line, vertical drop. Let me see if I can get this looking a little bit vertical here. And we're going to take a horizontal line across. So what I did is I dropped straight down from P2 and I went straight across from P1. So in your mind's eye, pretend that this was horizontal and that was completely vertical, which would mean that we would have a right triangle. Okay, we have developed a right triangle. Now this point down here, we are not going to give a new name to that point. We're going to express that point in these other coordinates that I already have sitting here. Okay, so let's figure out the coordinates for that new point. Now since this right here was P2 and these values are x2, y2, and since I came exactly straight down vertically in theory, that it's straight down vertically, then what would be the same value up here? Would my x be the same or my y be the same as this point up here? Since the new point is directly below, it's going to have the same x value as P2 does. So I'm going to put an x2 because that's what that one is. Since it is exactly the same height, this new point is the same height as the old point, the y's are exactly the same between P1 and the new point. So the y value will be y1. So we do have coordinates for this new point, x2, y1. So now when I find the distance between P1 and the new point, then since they are on the same level of the y's, they're on the same height, then wouldn't the distance just be the difference between x2 and x1? So x2 minus x1 is the difference between the x's and the distance between these 2 points. Okay, and then since these 2 points are having the same x value, so x2, x2, then the distance between these 2 points that are right above each other will be y2 take away y1. So the difference between the y's becomes the distance between those 2 points, and the difference between the x's becomes the distance between these 2 points. All right, well, let's refresh. What does Pythagorean's theorem say? For right triangles only, a squared plus b squared equals c squared. When I have a right triangle, that's an a, that's a b, and that's the c. Okay, so that's what the Pythagorean theorem says. A squared plus b squared is c squared. So let's take that and let's use this for our a and this for our b. Okay, so we're going to have x2 minus x1 quantity squared, which is our a in this one, plus, and here's our b value, y2 minus y1 quantity squared. So a squared plus b squared is, now I have represented this with a d for distance. This is what I'm trying to find, the distance between those 2 points. So we'll say d squared. Okay, so there is my formula, but what we just finished doing was learning that if we didn't want d squared, we wanted d, we could take the square root of both sides. So we're going to take the square root of that side and the square root of that side. Now, theoretically, shouldn't I put a plus or a minus out here? Yes, theoretically I should. But I am talking about a geometric figure, and we are only interested in a positive distance because we are talking about a geometric figure. So, although theoretically a plus or minus is there when you take the square root of both sides, in our application, we are only interested in the positive square root, a positive distance. So now I'm going to take my d and put it on the left, because I'm a little OCD like that, right? And I'm going to rewrite my square root of x2 minus x1 squared plus y2 minus y1 squared. That is our distance formula. Now, when you see the big picture, I'm hoping that that makes it a little bit easier for you. If you forget the formula, remember the picture. Okay, this distance here was the difference in the 2 x's. This distance here was the difference in the 2 y's. I'm going to square those 2 differences and add them together. A squared plus b squared is the distance squared. Okay, so hopefully that will help you in remembering the formula. So the difference in the x's squared, the difference in the y's squared, add them together and take the square root of the entire thing. So now we have some points. We're going to find the distance between these 2 points. So remember what I do. I take the difference in the 2 x's, and it doesn't matter which way I take the difference. It doesn't matter whether I get a positive or a negative number because I'm going to square it. So whether I take 2 minus 8 and get negative 6 and then square it and get 36, or take 8 minus 2 and get 6 and square it and get 36, either way I'm going to get 36. So don't worry about it. Okay, so the difference is 6. 6 squared is 36. I'm about needing a new marker. The difference in the 2 y's is 8, and 8 squared is 64. And I take the square root of the whole thing, and I end up with 100. The square root of 100 is 10. So the distance between the 2 points is 10 units. All right, so then we have another problem that we're going to find the distance between these two. So This x is -5. This y is a +1. They are a distance of 6 steps apart. So 6 squared plus the 8 and the 3 are 5 steps apart. So 6 squared is 36 plus 25. Square root of all that is going to be the square root of a 61. The square root of 61 does not simplify at all. That would be your final answer. All right, so now we're talking about completing the square. How are we going to, when we don't have a problem that's in the correct form, how are we going to develop a problem that has something squared? In other words, this is a really cool solution method, all right? We're going to solve equations by taking the square root of both sides, but sometimes we don't have a square on one side and we wish to make one. Okay, so this is called completing the square. And if I had f squared plus 10f and I wanted to make it a perfect square trinomial, what number would I need to add to make this a perfect square? So what I'm trying to do is get something squared. This is what I'm aiming for. Something squared on one side, so that in an equation I could use this square root property. Okay, the completing the square process has just 2 parts. Maybe 3, we'll see. Okay. The first thing I have to do is make sure that the coefficient of the x squared or f squared term is 1. If it is not 1, I am not yet ready to complete the square, and I've got to make that a 1. But in our problem, it is a 1. Okay, so the first thing you're going to do is check, is the squared term coefficient a 1? If it is, then you cut this coefficient of just the x to the 1 or the f to the 1, okay, that coefficient, you cut it in half. Okay, so we're going to cut it in half and get a 5. 5 squared is what I'm going to add over here. So I add the 25. Now, look, if I want to come up with the binomial that is squared, all I have to do is take my variable, drop it down, add a sign. Is it true? Is f plus 5 quantity squared equal to f squared plus 10s plus 10f plus 25? First term squared, this product doubled, last term squared. It is a perfect square trinomial, and it factors as f plus 5 quantity squared. Isn't that cool? All right, let's do another one. So we have something that's definitely not a perfect square. What are we going to have to add to get it to be a perfect square trinomial? This is a 1, so we're ready to proceed. We cut the -8 in half and get a -4. We square the -4 and get a +16. To find the number, the binomial that is squared, we just take our variable, drop it down. H minus 4 quantity squared is the factored form of our completed square. Let's check it. First term squared, product doubled, last term squared, and it works. We have completed the square, and we have made a perfect square trinomial that can then be factored. Okay, so this one's not quite so pretty, right? Because 11 does not cut in half. But the first term's coefficient is 1, so we're ready to go. We cut the 11 in half, and just use 11 halves. Don't go to decimals. It makes it tedious. Okay, 11 halves is good enough. So then we square 11 halves, and we get 1/21/4. Okay, so then we bring down our variable, and we square, and we check. Okay, so we got the first term squared. We got this product doubled, gets rid of the 2 on the bottom and makes it back to 11, and the last term squared. And this is now a factored form of our perfect square trinomial. Next, we're going to come back and learn how to solve problems using this complete the square method. All right, 3 more problems to be done with our video. Now we're going to use the same process to solve an equation. Now the cool thing is when we have an equation, we are allowed to add the same thing to both sides without destroying the equation. As long as we do it to both sides, it's legal. So the first thing I'm going to do is get my equation ready to complete the square. I don't need this 9 here. Right now, this is not a factorable equation. I cannot solve it using the methods I've already learned. So I'm going to take the 9 and I'm going to subtract it from both sides. So now I have v squared plus 4v equals negative 9. Now I'm going to leave a space here because I'm going to complete the square. And when I do find the number that needs to add here, I will also add it on the other side because I don't want to change my equation. I want to get it in a new form so that it's easier to solve. Okay, so now I'm going to look and I'm saying, okay, the first term is a 1. That's what I need. The next, I'm going to cut this one in half. So when I cut a 4 in half, I get a 2. When I square a 2, I get a 4. And I'm going to come over here and add the 4 to the other side. If I add the 4 to both sides, I don't change my equation. So now when I want to write this completed square in its squared form, I'm going to just bring my v down, put in a plus, put a square on it, and let's check it. First term squared, product doubled, last term squared. It works. So now I have a perfect square trinomial in its factored form. And on the other side, I have a negative 5. Negative 9 plus 4 is negative 5, which means I'm going to have complex answers. Now I'm ready to use my square root property. I take the square root of both sides, remembering my plus and minus. So the left-hand side, when I take the square root, I get a v plus 2. On the right-hand side, I'm going to get plus or minus the square root of negative 5. 5 is not a perfect square, so it's not going to come out. But this is going to wind up being plus or minus. The I is the square root of 5, remember? The square root of negative 1, square root of 5 is what we have. This part becomes the I. This part becomes the square root of 5. So I, square root of 5. And then to get my answer in its final form, all I need to do is get rid of this 2 on both sides. So I'm going to take away a 2 and take away a 2 on the other side. And my final answer is v equals negative 2 plus or minus I square root of 5. Okay, negative 2 plus or minus I square root of 5. And that is correct. Okay, let me show you the whole board so you can see any notes you need to get down on that one. Okay, so let's go on to the next one. All right, so now I have an equation. Everything's on the left, but it is not factorable. There's no way that you're going to factor that one. So I'm going to get the 12 on the other side by subtraction. So I get q squared minus 10q. I'm going to leave a blank because I'm going to try to complete that square. And I'm going to get a negative 12 on the right side. Okay, so now there's the 1 that I need. So I'm ready to complete the square. I cut the negative 10 in half and get a negative 5. I square the negative 5 and get a plus 25, which I will add to both sides so as to not change my equation. So now to get this into a squared form, I'm going to just drop down my q, put a square on the outside, and check. First term squared, product doubled, last term squared. If you're still not following my little pattern, write this thing down twice and FOIL it, and you will see that it equals that, okay? So then on the other side, we've got a negative 12 plus a 23 is a 13. Okay, so now we take the square root of both sides, and we end up with a q minus 5 is equal to plus or minus the square root of 13. So now I'm going to add a 5 and add a 5 to the other side right up there in the front. And my final answer will be Q is 5 plus or minus square root of 13. And that is the correct answer. All right, and the very last problem, we have a little bit of work to do. First of all, look at that mess. It is not in the right form to begin. So we're going to move the 9t squared to the front because that's my squared term. We're going to move the 15t there, and we already have our 3 on the other side. Now, notice that there is a 3 that I could pull out of the whole thing. To keep it as simple as I can, I'm going to do that. So I divide by 3, divide by 3, divide by 3, and I'm going to get 3t squared plus 5t is 1. Okay, I can always divide by anything that's not a 0. So now I have a problem. This is the first problem I've had that had a number that was not a 1 there on the front. But I need a 1. So I'm going to divide everything all the way across by 3. Fractions. Okay. So now this one right here is a 1. So I'm going to write a 1 right there. Now, remember, cutting fractions in half is not difficult because 1/2 of a fraction is 1/2 times a fraction. And 1/2 times 5/3 just means that I'm going to take the denominator and double it. Okay, so cutting it in half is the same as taking the denominator and doubling it. And I will get 5/6. So cutting 5/3 in half, I get 5/6. I square 5/6, and I get 25 over 36. But I must add it to both sides, 25 over 36. Okay, so that's what I have so far. To finish my little factor down here, I'm going to bring down my t, and I'm going to write it in its squared form. The left-hand side is now a perfect square trinomial, and this is that squared. First term squared. The product doubled goes back to the 5/3. The last term squared. On the right, could I make this simpler by writing this 1/3 as 12 over 36? Remember, equivalent fractions. If I were going to say, what am I going to need to multiply 3 by to get 36? You would say 12. So I have to multiply both the top and the bottom by 12, and 1/3 is the same thing as 12 over 36. So I'm going to replace my 1/3 with 12 over 36. So now when I add those two together, I'm going to get 37 over 36. Now I'm going to take the square root of both sides. So I take the square root of the left, I take the square root of the right with my plus and minus, and I get t plus 5 over 6 is plus or minus the square root of 37 over 36. Okay, but we just finished chapter 9, which was all about radical expressions. And remember, I can take the square root of 37 over 36, and I'm allowed to break that up into the square root of 37 over the square root of 36, which is square root of 37 over 6. Okay, so the square root of 37 over 6, and so I'm going to just take this whole thing and change it to the square root of 37 over 6. So now my final answer, I need to get t by itself. So I'm going to subtract a 5/6 and subtract a 5/6. So I'm going to wind up with t on the left, subtract 5/6, subtract 5/6 in the front of the plus and minus. And then I have 37 over 6. Now, because both parts are real, can I write this as one expression? So instead of negative 5 over 6 plus or minus square root of 37 over 6, can I take them both and put them all over? So all over 6. Okay, so we end up with t is negative 5 plus or minus the square root of 37 over 6. And putting them all over 1 is okay because we do not have any complex answers. Everything is real. Negative 5 plus or minus the square root of 37 over 6. Okay, does everybody see? We have learned how to complete the square. This is Mrs. A, and may God bless your day. That is the end of 10.1. We only have one section left.